This final activity, Asteroid Hunters, explores the ways that astronomers search for asteroids and includes information on the NASA WISE mission. This mission uses infrared sensors to detect small stars, distant galaxies, and asteroids. How do astronomers find asteroids that might hit the Earth? From here on Earth, most asteroids look like points of light, just like stars, except for an important difference. They move relative to the background of stars. They don't shoot across the sky like a meteor, but over an hour or so, through a telescope, you can see a difference in their position relative to the star field. Here's how it works. An astronomer hooks a sensitive camera up to her telescope and takes a picture of one piece of the sky. That piece of sky could look something like these dots. Can you tell which of these dots are asteroids and which are stars? No, not yet. Then, an hour later, she takes another picture that looks much the same. When you line up the two frames, any of the dots that moved over the hour are probably asteroids. The rest are stars. Here, we've made the dots in the second picture blue so they're easier to see. Let the audience try to line them up. Great. Here's the asteroid. This method works, but asteroids are still faint and hard to see. That's because they're small and generally very dark. Most of them are blacker even than asphalt, like this model of Ceres, the largest asteroid in our solar system. Because asteroids are so dark in color, they don't reflect much sunlight and are hard to pick out against the background of space. Here, I'll show you what I mean. Everybody get out your imaginary telescopes. Which of these asteroids would appear brighter to you on Earth? Remember, all we see is a point of light. Right. The lighter gray appears brighter than this very dark object. In fact, in a telescope, you might even be able to see this small, brighter one better than a large asteroid that's very dark. Remember, they're so small and distant that they just look like points against the black of space. We can't tell their shapes or how big they are. So scientists came up with different ways of detecting asteroids. The idea is simple, really. I imagine a lot of you have been out in the sun wearing a dark t-shirt. Did you notice how you got warm? Well, the same thing happens to asteroids. The sun warms them up too. Scientists thought that if they could just measure how warm the asteroids are compared to the space around them, maybe they would be easier to detect. And that's exactly what they did with special cameras called infrared detectors. These basically see the temperatures of objects. Here, take a look at this picture. This is a regular picture of two warm rocks against a cool, dark background. Can you see the two rocks there? The second one is hard to see, isn't it? That's because it's very dark. Well, on the other side is a picture of those same warm rocks taken with an infrared camera. Since both rocks are warm, they appear very bright in this picture. Now you can tell how big this one is. Do you think this technique might help us in our asteroid search? This is that same star field I showed you earlier, but taken with an infrared camera. Do you see more dots? Yeah. Do you think they're stars or asteroids? Let's find out. Here's a second image taken in infrared an hour later. Try to line up the dots now. Compared to the cold background of space, asteroids shine brightly in the infrared, just like that dark rock in the picture. You can see that a lot of the dots have moved over that hour. Those are all asteroids. Look at all the asteroids that infrared detectors can find. NASA's WISE mission is orbiting Earth above the atmosphere and taking pictures of the sky with infrared cameras every hour. This is a very good way to find asteroids. You can find a reference page of PowerPoints related to the WISE mission on the Manual and Resources CD.